a W3 school site.
Okay. Now, so can we just take an example and can you help me solve that problem which was there in the PYQ? Is that doable?
In the
PYQ?
okay, like you, it means you are telling PYQ in
Yeah, I can
PYQ.
share that if you allow. I can share the
Yeah.
screen if that's okay with you. One second, I'll share the screen. I'm referring to this question first. Question, couple of other questions which are related to this. This is very intuitive, but again, I didn't know the logical approach to solve these, right? So can we just look at this one? How do we solve this? I was thinking of 15 as the answer.
This is there in the graded assignment or
No, this is a PYQ. Yeah,
PYQ quiz questions.
yeah. This is a previous quiz question.
Oh, previous quiz questions. Okay.
Yeah.
Sorry,
There's
I'm
only
not
one
understanding
previous
what is this.
there's only one previous quiz that's available for this subject looks like. So I was not sure. I mean, I think this is the only one that we have.
In a language where adjective changed change based on weather and state is decided to transform happy to happy rain on rainy days at the sun on sunny days. Sophistic has five states of happy,
So if there are
three
five
states of
initial states and then three
condition.
extensions of each, then I was thinking of 15 as the answer, but it says 11. So I don't know how.
What the minimum? What the number of states required? Okay. So it takes happy and three weather the states. One. Okay. How come it will be 15? Can you explain?
No, I was thinking of five possibilities for the, I'm just doing the permutation kind of a thing. Five
Yeah.
possibilities for the initial state and three attached possibilities for the extensions, right? So 5 into 3 is 15.
Ha ha
But it
ha.
says 11, so I don't know how 11 because I'm not able to do that math myself. And this is the first question actually in the quiz.
Okay. I even am not sure much about this
Okay, no
festive.
problem. There's another
No,
question which is
one. Can I
Yes,
intervene, Priyanka?
yes, yes, ma'am.
So here, so what's given is
And
happy, and happy can go to either happy rain or happy
uh,
can go to happy sun,
happy
right?
sun. Huh.
And it is given that five states for happy we have to use, and three states for each of the weather conditions, which means
It is
five states for happy, three states
uh,
for
mm,
rainy weather, three
the
states for
mm,
sunny weather. So
so
that is
it's
5
just
plus 3 plus
adding.
3. That
Huh.
that is 11. So that's the minimum number of states required, right? That's what
It's
they are
only the
asking.
total. Okay, total minimum number of states. Okay, yeah.
Right,
Uh,
Animesh? Does it make sense?
yes, yes.
Basically, his understanding is like he is multiplying so that he will get different, uh, like combinations of the what you call the
Yeah, I get
states.
that. So,
Huh,
but
yeah.
here there are only two possibilities, and
Mm,
uh, you know there won't be any multiplication,
Okay, there
right?
will be an
So
mm,
addition, like, okay.
they're
yeah.
just asking total number of
Fair
states,
point,
right?
fair
So
point. This was kind of when I see the answer, I can easily say that this is how it will be. But I kind of so basically maybe I'm lagging a concept based on whatever I've seen in the video. So I was just asking for this, like say for example, this question. This is another question. So there are three back-to-back questions like these.
Okay.
So it says
This is
FSA recognizes
FSA,
the
right?
yeah. Carry on.
Actually, last time, ma'am, we also found some problem with these questions, right? So that is why this time I've tried to avoid these questions. Yeah, there were like problems in these questions also. But in this, let's try. If I recognize the word that begins with an if, then the state transitions are defined as while middle is an accepting state. So, what are the options?
Options were when I look at the options becomes
Uh,
very clear. The answer becomes very clear. But I was just not able to logically put it together. Maybe it's very simple, but I maybe I'm lacking that knowledge.
So initial states, it's just telling the states, right? From the
Yeah.
when Q Q naught go in like zero stage, Q0 stage go to, if it is at a U, it is zero, it is Q1. From 0 to U, initial state, it has, see, FSA has initial state and accepting state, right? So it starts with the initial state and then goes to U. So it increases the states, right? Q1, Q2, Q3 based on the moving from the for like based on the its movement, the states do increase, right? So it is what they have said. So for which of the following inputs will FSA is the accepting stage? So Q4 is the accepting stage, right? From Q3 to Q4, it is the accepting stage.
So are we saying as long as we have an UN in the beginning and ED at the end, anything in between will be
Yeah,
acceptable? Is
it
that
is
what
the
you're saying?
accepting stage.
Okay, fair point. And what about this one then?
Uh, is recognized language that end with the Q2 after one accept stage. Here, so here Q1 on the input one goes to Q2. This is an accepting stage. So in the question itself, they are given, right? So FSA recognize binary strings that end with 0, 1. So here it's ending with 1 last. So it like ending state is 1. So it is the accepting state. So what is the output of FSA when the for the input string 1, 1, 0, 1. So it is accepting stage. Right? String is because it is ending with 1.
Yeah. So
Q2.
no, how did we actually resolve for this one, 1101 when we say, and there is a specific set of transitions given, right? So how are we logically approaching this is what I wanted to understand.
Logically,
Okay,
I
so Animesh, so in such a scenario, you might want to draw in rough the state diagram,
Hmm.
and then follow the given string. Well, in this particular question, if I remember correctly, so what was incomplete was Priyanka, when we are on Q naught, the initial state, and let's say we get one, then
mm,
where do we move? That transition, do you see here? When you are on Q naught and you get a one, where do you move? That incompleteness was there, right?
yeah,
So
yes,
Q naught, you get zero, you go to Q1, that's fine. But
Q1. Mm.
what do you do when you get a
From
one
Q1,
on Q naught? So that is not mentioned here. So that kind of is an incomplete state diagram.
Yeah,
That's
whereas
that
the
was the
example requires us to start with one only. So that's
right,
why I was
right. So
very
that was
confused.
the incompleteness, and that's
Okay.
why this question was ignored that time. So
Okay.
yeah,
this PDF is not updated with that
Okay.
correction. Yeah.
Okay,
okay.
fair point. And I observed a couple of places where I'm not sure, maybe there is a calculation correction that's needed. Once again, I'll just try to pull it up out from from the slides only. And those are very important parts. For example, this was the entire foundation for the calculations that we are doing in
Mm.
the subsequent slides, emission probabilities, transition probabilities, and all. And somehow I feel these calculations given here are incorrect. Maybe I'm wrong, but these map values are not matching with the ones on the table. The table that's been explained before is
Okay,
something else, and this is
okay,
something
I
else.
didn't observe that. Yeah, okay. So, but you understand the concept, right? How we are
Now,
reaching
the
the
only thing that leaves us a little confused is because this is the only example that was there, right? So even if I understand the concept, unless I see a solid example of that, I will not be very confident about it. Is the point, right?
Right,
So
that is that is understandable, Animesh. Can you do a favor, please? Can you post this in Discord so that we can make a note of this and get it fixed?
sure. I was
That is
not even
actually
sure if this is wrong. Maybe it's my understanding only, but I was not able to map these
we
values with
can
the
cross
table
check
given.
this.
Yeah,
So
yeah.
yeah, we
right,
can do
we can
cross
cross check
check it. So
this
I think there
later.
won't be any mistakes actually.
Hmm.
So maybe yeah, but still we can cross check it.
Yeah, so I was
Okay.
because this could be again a some. I mean, this I believe is something which is very important as a concept. So I was just wondering how to go about it, right? So this is one of the things, and there's one more. I believe that's the next week. One second, week 4. This is here. I think this is again
In the
something.
label attachment scope.
Yeah, I couldn't really follow that, and I think the professor also said something different. Then she corrected, but slides were talking about something different. So yeah, so I couldn't understand this score. I could understand this piece, that one of the labels is not matching this. Maybe 4 and 5 is a mismatch,
Uh,
but I couldn't
uh,
understand what is this 2 by 5. How is this coming here?
uh, 2 by 5. So
Hmm.
LAS is the basically accuracy of both head and the dependency table, right?
Hmm.
Label attachment score.
Hmm.
So here one tag is that means here both the head and label should be correct. So when you see the past side here, uh,
There are two mismatches that I see here.
video and the see, let's see the what are wrong. We have three incorrect tags here. So one is the uh, third one, third token. The here label is sorry,
Label, okay.
not the what you call
Label is correct, but tag
label
is yeah.
correct,
Okay.
and the head assignment dependency is wrong.
Okay, head is incorrect, is what you're saying, right? Label is correct.
Yeah,
Head is incorrect. Head is
head is
ideally supposed to be 5, but we are marking it as 4.
four.
Label is determiner here and terminer here as well. So that's not a problem. Fine.
And in the fourth token, end subject, it is wrong.
It is
It is
wrong.
non-modified. It should be
Right.
but
Right.
non-modified.
Right.
So this is one, two, and in
Okay.
the fifth token, this what you call label. Sorry, label.
Hmm.
Label is wrong. C-comp. C-comp
Hmm.
is incorrect. It is direct object. So we have one is with the label and one with the heads. So like three wrongs are there. So that is two corrects. So only first two tokens are correct. So we are so LSA is the accuracy of both head and dependency label, right? So it is 2 by 5.
Okay. So then the doubt that I'll have is that in cases where both the head and the labels are incorrect, would we count it as 2 or 1?
Then it is still it is incorrect, right? So we will not take it for LAS. We'll be counting layers only when head and
Both are
dependency
correct. So it's
level are
more of an
correct.
and thing that we are checking. If
And
one of them goes wrong, it's
it is
considered to
wrong.
be a 0. Okay.
Yeah,
Fair point.
it
Fair
is
point. Got
zero.
it. Got it. Got it. Got
Yeah,
it.
if only head assignment is correct, then you're
Yeah.
calculating UAS.
Fair point.
Uh,
Fair point. Got it. Yeah. So, I mean, if you, I had these specific questions. If you have anything specific to talk about or anything from your agenda, you can just carry on with it.
okay, I just
Maybe I can
uh,
stop sharing now. Sorry. Yeah.
yeah. So I have prepared some revision sessions like through from 4 weeks. So maybe I can just present it.
Sure, please.
So I think my screen is visible. Okay, I'll
Yes, it
go
is.
to so this is the revision session from week 1 to week 4. I'll just uh, quickly, you know, touch all the topics, try to cover all the major concepts in the week within these 4 weeks. So let's start with understanding what is a language. Basically, natural language refers to the languages spoken by humans for everyday communication. So we are using this. We are see, what we are doing in NLP is we are just using these languages to make the machines to understand, interpret, and generate human language in the way that is more valuable and meaningful. So it combines with machine learning, deep learning, and other AI techniques. So basically, what do we understand when we tell? a language. It has this components like phonology, morphology, syntax, semantics, and pragmatics. These concepts we have already discussed early in the tutorial sessions also. So maybe like yeah, in furtherly also I can explain this. This I have added. So what is NLP? Basically, we are having a language. We are teaching the, you know, teaching the computers how to understand the language, and it is generating the language through other modeling and technical aspects. With the technical aspects. So we have seen how NLP models have evolved through time. It begins with the 1950s to 1960s. 19 till 1970s, all the rule-based era was developing, or like people are working on the using the rule-based systems. In this late 1970s, the concepts of case grammars, conceptual dependency theory, semantic networks are evolved, and then we have come to the expert systems in 1980s. Then, there is a transition to the statistical models and neural networks. All this we have uh, covered in our lectures in detail. Uh, then, then we have introduced the graphical representation of the vectors, where the common entities do have the similar, what you call near representations, like king, queen, man, woman. Uh, like it depends on the vectors of how we are defining them. Then word embeddings have came into picture. The LSTMs, RNNs have come, and encoder decoder models have come. Attention mechanisms have been popular. Now we are in the era of LLMs and all. So, and we know all these concepts. I think in this course you will be further learning them all in the detail in the further weeks. So, let's start. Why NLP is hard? Because it has a lot of ambiguities in language. It can be categorized into different levels of ambiguities. When it comes to lexical ambiguities, we you know about the homonyms, polysemious words, part and hyponyms, part and whole. What do you call part and whole paradigms like these differences maybe you have learned in the in this lecture, or in, and maybe you are aware of this, I believe. um, so it is lexical ambiguity is deals with morely with the meaning of the words. In syntactic ambiguities, it since it syntactic means it is a structure of a sentence where in which we can have an attachment ambiguity and coordination ambiguity. This were also explained. Um, so attachment is the where the uh, a phrase or a noun phrase or some prepositional phrase can occur in more than two different positions, which changes the meaning of the whole sentence. And in the same way coordination ambiguity as well. So so all this makes a model to understand this ambiguities. So semantic ambiguities are also seen, which deals with the semantic, with the meaning of the sentences, uh, which has like quantifier scope is there, anaphoric elements is there. Anaphoric elements as in there are reference and referring expressions. There will be in some cases there will be ambiguity between how how this referring expressions are being referred. Some examples were also explained in the slides in the lectures. So pragmatic ambiguity here, it is more of social concept. there will be Deixis is where which deals with the uh, time and the place components. In speech act, as in it is like so there will be ambiguity of one whether a sentence is being in an imperative mode or in the request manner or it is a declarative. There will be some confusion in that. So these things do come under social concept, social understanding, as in it depends on the context in India. So that in these things may model may not be really clear in understanding the uh, like modes of how a sentence is spoken, and we know how the irony and the sarcasm implies uh, depending on the context or something. So why NLP is hard? Because in linguistic diversity is there. There are many language families. Each language has the different what you call linguistic understanding or levels of different stylistic features, not stylistic features as in like different linguistic um, what you call representations in the phonology or in the morphology, in the syntax, and when it comes to syntax, the change in the word order, and so many things it has. And also there is a language variability across the speakers, like different dialects, sociolects, idiolects, these all we have discussed. And languages also do evolve, like some words in our languages may do go through some adaptation, like they may see there will be um, see new words also are can also are being introduced into our languages. And at point we use a word which has some meaning, but the through time uh, we may not use that word in the sense that we use in earlier. So in social media also we do find so many of such words. How the mostly in social media we can see how language is evolving. And of course, this cultural, and ethical considerations are do there in this. Are, this also adds to the linguistic diversity. And moreover, there is low resource languages. There are where we have the scarcity of data and though we have they may not have a good quality of data available. So levels of language processing in NLP, as I was discussing, phonology deals with the interpretation of sounds. Morphology, it is the how the words are analyzed, like how it is the tense, aspect, mode, gender, number, person. All these components are studied in the morphology. So in lexical, this it is just the interpretation of the meanings, and in syntactic, it deals with the structure of the sentences, how to make a sentence a grammatical sentence, or acceptable sentence. Semantics, it determines the meaning of the sentences by focusing at the word level meanings. Discourse, it is a broader concept. It mostly deals with the coherence and the cohesion between the sentences or in the text or in a document. Pragmatic, as I said, it more of the social context, like depending. It's a language in use in the situations. So levels and applications in NLP. So processing lang. Uh, mm, so these are all the processing levels and its respective tasks and applications which we are you know which we are using. So in the character and string, it has these word tokenizations, text pattern extractions, and all. In the word level, of course, there will be pure tagging, NER, chunking, and all. At the sentence level, sentence classification, on question answering, retrieval and ranking, all this NLP tasks and applications are there. So yeah, you can go through all this. Then, what is the NLP pipeline? As in, first it should be starting with the data collection. Just a second. Just a second. Yeah, sorry. So it starts with data collection, uh, and and have to begin with the data collection. Goes with the further processing for like text cleaning, normalization, everything, and then comes the modeling part. Then and evaluation is a essential thing in the pipeline, and its deployment and the monitoring and model updating. So this is like something very naive way of naive as in like surface level understanding of how the NLP pipeline you know can be understood. So in data collections, there are obviously will be some challenges like data quality should be taken care, and its privacy and security issues uh, are like the major you know challenges that we are facing now. And there should not be in our data we should take care of the bias like gender bias or any community based bias or something like that should be also be keep and should be kept in mind while collecting the data. And then comes the text cleaning, as we have already discussed, like removing the noise data, this normalizing the text, the slangs and abbreviations are to be taken care. In text processing, sentence tokenization, word tokenization, lowering stop word removal, normalization, and stemming and lemmatizing techniques are also we have seen. So stemming is just like the stripping of the affixes, which sometimes they do not convey the meaning or the of the root word, but lemmatization, it is a dictionary based word. We will like uh, lemmatization is like a where we after its application applying we will have the our root word will be the which has the complete sense. That means that we have the dictionary based word. But in stemming we may not expect the complete sense of the word. So building blocks of morphology, all this comes under the part of we are at the word level now. So morphology, it deals with the morphemes. uh, so here morphemes are free and bound. We have, I think briefly, it was explained in the lectures about the lexical, functional, derivational, and inflectional morphemes. So lexical are the open class words. Functionals are the closed class. So free and bound are like free morphemes. They all the affixes are attached. In the bound morphemes, it, they cannot stand alone. They need some uh, content words to be you know glued to form a meaningful word, or to for two basics of divisions of morphology, inflectional morphology and lexical morphology. So in this morphological analysis, we have we have seen the isolating languages where we have the individual words with different with each word have its own grammatical representations. So and we have the agglutinative languages like Tamil, where each uh, each word has this morphological uh, category, or the what you call like each in a word it has all the each morpheme has its part, has its grammatical role in the agglutinative languages. So in the fusional languages, it is like a more fluid one where um, like uh, maybe a one word can give the whole sentence meaning. Maybe maybe like dividing or analyzing the um, word into different like according to the different grammatical role, maybe it will be difficult in those languages. And same goes with the polysynthetic, they are highly glued. Maybe in some other languages it may need a whole sentence to give one meaning, but in the polysynthetic languages, maybe a one word can explain the whole sentence in these languages. So morphological modeling deals with the knowledge of the words. We have seen item and arrangement, which is morpheme based. Item and process, it applies rules to the new words. Uh, Here it deals with the sequence of concatenated morphemes in item and arrangement. Here just deals with the concept of allomorphs. Maybe this polymorphs and all are clear, and maybe are clear. I'm not going more deep into this. And comes the word and paradigm, where we have a word and it's based on the affixes it has. Words are uh, divided in, like, different words has different paradigms according to the affixes that they are getting, you know like, let's say cut can be considered as a paradigm for the words which has the uh, like cutting, cut. So past tense, present tense, and future tense, it has one pattern. But when it comes to play, playing, played, so these words, this play and cut are considered as two different paradigms. So this depends on the affix that is getting glued with these words. Pure tagging, yeah, what is pure tagging is the assignment of parts of speech words in sentence. First, these are the basic uh, pure tags that we know. And in challenges, yeah, multiple categories can be there. So some words can have multiple categories. Can, the can. One here, one is a name of a person, one is a model verb, one is a what you call a can, the actually noun. In the same way, we have garden path sentences and unknown words. So next, word classes, we already discussed about the open class and word class. Here open class words are the new members that can be added, and the closed class words are the relatively having the relatively fixed membership. I mean, like, they are like new entities, like new words cannot be uh, formed in here. And next is pure stacks. We have different types of pure stacks. This is the universal dependency pure stacks. In the same way, we have for Indian languages we have BIS stack set. So that is there. And Penn Disco Tree Bank also has, sorry, not Disco Tree Bank. Penn Tree Bank also has the pure stats. NLTK is also has the pure stats, its own pure stats. So, but for Indian languages, when we are working on Indian languages, there is a tax set called BIS tax set that is, followed for the that is like the for that, yeah, basically that is used for the Indian languages. So this is Tree Bank the set, the tag set, and methods of viewers tagging. So from rule based viewers taggings are the transformation based, where the rules are used uh, to correct to the viewers tags, and statistical based on the probability of the tag. Um, Tags are assigned, and in that hidden HMM are there, maximum entropy CRFs are there. Then machine learning based pure taggings are also available. Then it's basically rule based. We know that it starts with the rules is starts with the dictionary words and its possible tags. Assign all possible tags to the words using the dictionary. It writes rules by hand and selectively removes the tags. So here it has transparency, customization, and here no training data is required. But the cons are limited coverage, scalability, and the performance. So transformation based talents are initial stage. Initial state it is naive level, but often using the simple method like most frequent tag. So transformation rules are there to correct the current pure tag based on the context. So here it identifies the current tag and the rule is applied and we have to iterate it up. It automatically iterates to the next word. Final output is a sequence of rules applied to improve the accuracy, tagging accuracy. Stochastic deals with the um, probability of the sequence of tags, and these are there are two types of probabilities: individual word probability and the tag probability. Based on that, here um, stochastic probability tagging works. Then tag sequence also has this, maybe this works. Oh, so bigram model we have trigram model and basically ngram pivot ngram model pivot tagging is also, you know, is also can be applied for the pivot tagging. Okay. Then HMM maximum entropy CRF models are the common pivot model that are available. Maybe for Indian languages also, CRF models are available on online. Um, so is evaluated through precision, recall, accuracy, and confusion matrix. Uh, then comes NER. NER we know it is named entity recognition. It has person names, organizations, locations, and like there is some tag set for that. Um, Helps in extracting valuable information from the unstructured data. This is their it applications are sentiment analysis, information extraction, question answering, and all. We also understood what is any what is a named entity and what is not a named entity in the lecture. That thing, yeah, you have to be aware of eh, while like if while performing any task on anyone. So these are the tag set schemas, like tagging schemas, like BIO, beginning of the entity, inside entity, and outside entity. In and it has some other variants also. So sequence labeling and standard algorithms for NER are same that are used for the pure tagging only. So hidden Markov models, conditional CRFs. Now we have come till the large language models with through the app. Uh, yeah, we are in the era of the LLMs for this task. NER challenges and metrics. Yeah, these are some types of ambiguities, boundary ambiguity, overlapping entities are there because Indian languages are like diverse diverse language families and they are morphologically rich and low resources, no capitalization feature is there. So these are some challenges for the Indian languages. And metrics are precision, recall, and often. And modern metrics are exact match ratio and entity level one score. So hidden Mocha models like it has the um, transition probabilities and emission probabilities. Transition probabilities is the probability of transition from one state to another. Here, like it is a probability of a verb following a noun or a noun following an preposition or in English it is a preposition followed by a noun. So in this emission probabilities. It's a probability of observation generated from state. So it is the probability of the word here rays being generated in the given state or is a verb. So race can in the slides it has explained race also in some cases it is possible there is a possibility of race being a noun as well. So this is this emission probabilities calculates the probability of the word and its pairs and its tag. Initial state distribution it is a probability distribution over the initial states of the probability of the first word in the sequence as a noun. Yes. So it has key algorithm, forward algorithm, backward algorithm, vertebrae, and Voltage algorithms. So it's here is the assumption is that current state depends only on its previous state. So here it has the predefined number of states. Uh, so there will be a you know difficulty in estimating the probabilities with the limited data. Oh, but also the HMM struggles with the capturing the long range dependencies in the maybe it may not capture the context of a word in which it is occurring. So there could be probability of incorrect tags as well. So maximum entropy it is directly models the posterior uh, probabilities, that is tag probability of the tag with the word. So it builds a distribution of adding features, realizations, happens, and word rings and all. So this is also a deterministic probability model of the label sequence given in the observation sequence. So okay, I think I have some updating I have missed, I guess. So um, sequence modeling, predicting or labeling the sequence of the data here same. The HMM and uh, maximum entropy models and CRF works. These are the sequence models and classification of models for POS and data. We can use naive Bayes, logistic regressions, and clustering. So naive Bayes is the as a simple probabilistic model assumes independence between the features, often used for POS tagging and NER. It predicts the so logistic regression predicts the probability of pure stacks and can be extended for the multi-class classification as well. Here, clustering is the grouping the words into the clusters based on the feature similarity of the words. Mm. So this is how namespace is calculated. Uh, this is it's like with the probability. I think we have I think I'm not going to go in detail on this. Running out of time. So predicts the logistic regression in NER. It predicts the probability of the word being an entity by leveraging the features like capitalization, word shape, and the position in the sentence. As I said, it is a multi-class. It can be used for the multi-class classification. K-means clustering. It is grouping the similar like words of similar context into the clusters. So syntax. It's a set of rules, principles, and process that govern the structure of the sentence in language. We have already discussed what are the lexical categories, functional categories, and phrasal categories are the noun phrase. If it is in a noun phrase, noun is the head of the phrase, and adjective determiner. So the categories which are in the brackets are the optional. Um, yeah. So here in a noun phrase, head is the mandatory category. Like noun phrase has noun as a head as its head, and verb phrase has verb as its head. In the same way, prepositional in prepositional phrase, preposition and is followed by noun in English. That means preposition phrase cannot come. A preposition cannot just come alone. It always has the noun followed by to be followed. Um, and the phrase structure grammar. This is how the um, you know how the phrase structure grammar phrase structure tree is represented. It has the rules like sentence. It has NP and VP. Then NP is divided as the determiner and the head noun. The VP has the verb and the prepositional phrase, and prepositional phrase has its preposition and noun phrase as its categories. So context-free grammar is a formal system describing the syntax of syntax of natural language. Use the production rules define how words and phrases can be grouped or ordered. So these are only some rules how to express how symbols can be written as other symbols. So these rules are basically taken from the pen tree bank. This is also some graphical representation of syntactic structure of the tree. But this has this tree. This is different from this. This tree representation is different from this tree representation. Um, so here grammar is okay. These all normal. Yeah. So the same thing. This is same like this one. This tree structure. These rules are, and these are just the lexicon. Constituency passing. It is the syntactic structure. It is a like analyzing the syntactic structure of the sentence by breaking downing into the constant parts. So here this group of words do function as a like single unit in a sentence. So cat sat on a mat. Noun phrase enters a cat sat on the mat is a verb phrase. So here in this, so we'll see how KYC passing works. So we'll write a sentence, and in diagonally we'll give the POS tags, and so for each cell we'll consider the all possible ways to split the substrings into two parts. So check the grammar rules for combining the two parts and add any valid constants to the cell. It's like we are filling the table from the top right top right and have to end. The whole point is we have to reach to the sentence to the symbol yes, where the that means that sentence is a valid. I hope you understood this.
Now, if you could explain this a little more, it will be helpful.
Huh. So here book the flight through Houston. So here Houston is a proper noun. Is a proper noun. Through is a preposition. Flight is a noun. The is a determiner. Book is a verb, right? So here then we are seeing the so we are this one, two, three, four, five are the tokens of the sentence. Like token one, token two, token one, token two, token three, token four, token five. So so word four and word five has the as the relation of preposition. Okay, it's a prepositional phrase. Through is a preposition. As I said, preposition is followed by NP always in English. But in when it comes to Indian languages, it is different. In let's say if for Telugu, for Dravidian languages, like we have postpositions. That means so after noun we have the postposition markers. So that is different case. Okay, I'm not going to that. Sorry. Through Houston is a prepositional phrase, and here um, here so 4 and 5 has the NP relation. Sorry, 3 to 5 is the PP. 3 to 5 flight through Houston, it is a preposition phrase, and 3 and 4 is the 3 and 4 is a preposition, and 4 and 5 has a NP relation. So, and a flight is a 2 and 3. 2 and 3 has the it is also a NP here, NP, and 1 and 3 has the VP. Book the flight. Yeah, it is VP here. So this is how we have to see the how each word is linking with uh, how each word, how each word is, as a linking as a modifying or specifying something. So depending on that, maybe for this, you should have the clarity about what is NP, VP, and prepositional phrases, and there are some other phrases as well. So that knowledge is required here. So this is how, like, we'll go to bottom to top approach, where you'll find you have to see the dependencies of between the words and come to the uh, you know they this is how to construct a complete sentence here. That means like passing a complete sentence. Yeah. Here in this dependency passing, focus on the relation between the individual words, not larger phrase structures. Yeah, I was telling about the and so yeah, this is also maybe useful if you understand what is end subject, object, I object in the um, like if you're performing any dependency task. So if there is in universal dependency website, you have the proper explanation of this all these tags. They have like very very much fine grained guidelines to further syntactic annotation guidelines, and they also have the POS guidelines. Like there is like it's a very good site for the for understanding all these concepts. Maybe you can refer that. And transition based tagging is also it's a shift reduced approach. Here you have a stack and word list. So it's a action and like here the words too added. Yeah.
So there were
So
a couple of places
book
here where
me,
I was not able to. Sorry,
book me, huh?
there were a couple of places here where I was not able to really map the purpose of shift and left arc and right arc. If you could explain that, that will be nice.
Huh. So here, first stack has the root in the first word. Let me open this slides also. So from there, here, this is like kind of compressed. This is transition based dependency typing. Let's see. Okay. Uh, so in this, this is a shift and reduce approach. Okay, it has a stack which is used to hold the words being processed, like buffer stores the remaining input words to be parsed. Okay, and it has an oracle determines which action, like shift, left arc, or right arc, should be applied to the words on the stack to create a dependency tree. Uh,
Sorry, are you sharing a different screen because I still see the same
no,
slide?
no, no, no. Okay, should I? I'm just seeing this the PPT that was shared with you. Do I have to present it?
No, no, fair
Like,
point. I just thought maybe if you're sharing something else, I was not able to see that. No problem.
so
I'm
I'll just
in the
come
earlier.
to there. Okay, done. So basically, what left arc does is it's an such a head dependent relation between the top two words of the on the stack, removing the second word from the stack. Okay, right arc, it's a head dependent relation between the second word and the top word of the staff, removing the top word from the staff. Word from the buffer to the staff and progressing the sentence. And so basically from this, let's say book, we have a at the step 0, we have a root and a word list, and we have to perform an action. Here, shift book. That means it adds a word to the stack, and then there will be a so then we have root and book in the step 1. So we have to, here the action is shift because root and book has there is no dependency here. I mean, like there is nothing to mm, what you call relate. Then we need another word to relate. So in the step 2, we get another word me to the stack. Then it is book me. It is a book is a verb here, and me is a pronoun, or like let's say nominal. um, so it is a right hack. That means book is has dependency with the me. In the same way, uh, root and book. So now me is excluded here. We are removing the me. Now we have root and book in the stack. In the step 3, in the word list has the morning flight. So here we are shifting because the and book the is we want. I mean it. We want. Actually, it should be here, right, Akash? Book the. No, already we have done with the me. Me is there. Me. So here it is a shift because book and the do not have any dependency. Then we are going with the morning. We are adding one morning to the stack, and in the step 5. So book me the morning, and here morning, the and morning relation. Okay, it is taken as in a phrase, right? So okay, so shift. So here also it is shift. So here left arc is in the step 6. Now the stack has book the morning flight. Left arc is flight is has a modifier morning. I mean it's a specifier morning. So it is a left arc. So flight, which flight? Morning flight. So it is in the left direction. So that is it is left mark. So before morning, it we have book here. Uh, like, and the is also a left arc. The is a specifying the flight, and right arc book. Now we have route book the flight. So it is book what we are booking. What we are booking the flight. So it is depending. It is right arc because it is depending. What you call it? It is, yeah. Book as a subject and object, right? So book is a verb. So object is flight. Is the flight. So it is so it is in the right. It is the right side of the book. So it is a right arc. And yeah, in the same way. So now we are done with the forming the all the whole sentence structure. So now we are ending with the root alone. I think this make clear anyhow. Is it? Yeah. Okay. Oh, transition, and this is graph based. Searches a space for all possible trees in center and selects the tree with the maximum score based on the dependency edges. Next, this also we have discussed, like labeled and unlabeled attachment scores. Depending on the accuracies of the heads and its dependency labels, these scores are calculated. Mm, So, logical semantics overview. This is like logical semantics. It's the study of meaning with logic. We also have this first order logic. Here, Saint John loves Mary. Logical form: loves John, Mary. Predicate is a love, and the arguments are John, and Mary. Here, this interpretation is can be used for reasoning, querying, and making the inferences. So, semantic role labeling is a process of identifying the roles of the words in a sentence, captures the relationship between the predicate and its arguments. So, it helps in understanding the meaning of the sentences in the tasks like translation, summarization, and the question answering. We also have the probe bank and framenet. It here like you can go to this probe bank and framenet sites, how they are representing the arguments and semantic role labelings for the verbs and nouns. Um, yeah, I think we are done. Yes. So till week 4, I have tried to revise the portion. Still, if you have any doubts, yeah, please.
I think it should be fine. It's like it, like I said earlier, when I went through the graded assignment and the quiz, I could sense a difference in the level, right? So are we expecting that it'll be more aligned to the graded assignments this time?
More? Sorry.
Aligned, I mean, our quiz will be more aligned to the way graded assignments are. Is that how we should anticipate it to be?
Yeah. So basically, you have the pattern of MSQs and MCQs, right?
Right.
So in quiz also you can accept that kind questions only. So I mean, I'm not understanding. Can you clear me on this? So
No, no, no.
you're
So,
feeling
like I said, that
quiz
when I
are
look,
wait one second. Quiz are more or higher level than grade assignments, or graded assignments are higher level.
so the difficulty of
Mm,
the quiz was a little different. I kind of stated that through that example, right? So FSA and FST, if we just
mm,
went through the slides versus the kind of first three questions were there was a difference in the level, and we didn't have
yeah, yeah,
similar examples
yeah,
there, right? So I was
yes.
talking from that perspective that quiz seemed to be a little different, as in the level of difficulty was a notch above our graded assignments there in the quiz, and that's the only quiz that was available as a model to refer to, right? So
Okay.
that's where I was asking, should we expect something more in line with our graded assignments? Because graded assignments are relatable, very relatable.
Mm,
When we go through the slides, most of the, I mean, 80% of the graded assignment makes sense to us. 80, 90% makes
okay.
sense. Yeah. I was asking that from
Okay, yeah, you can mostly expect the graded assignment type of questions only, but maybe there will be little bit advancement, so we have to give in the quiz, right?
you. No, definitely,
So
definitely. I mean,
yeah,
there has to be
uh,
some differentiator also,
yes,
to people who would have put some extra effort and things. So I totally understand that.
yeah, uh,
It's just that the overall theory in this subject is like so far, because we're getting to know a lot of terms. Now,
yes.
extending those terms
So
beyond that time gets.
basically, this part of the lecture, I mean, this I think from week 1 to week 5, you have mostly the theoretical concepts only. So maybe in the further sessions you have the ML part, where the all the models, or like all the like HMM, Naves, all this are maybe clearly explained in the further weeks, I guess, if I'm not wrong. So here we are not much dealing with the mathematical concepts or mathematical concepts. We are just trying to, give you the understanding of linguistics in computational perspective, or the, uh, you know, uh, like all the in the language perspective. You probably have to understand how to deal with a language when you're doing something, like how you can how you can evaluate your model when you see an output generated through your model, like whether it is semantically doing well or not. whether the construction sentence constructions are good or not. So in any task, so in the mission translation also, like you will be having, so you will get your output, but some, in most of the cases, the sentence constructions will be good, but semantically that do not make sense. So all these things you should be able to evaluate. These things you will understand only when you understand you know not when you have the knowledge of these concepts, like what you call, mm, this, what is morphology, like not let's not, if not deeply into morphology phonology, at least like semantically, semantics should be, you must be having idea when you are dealing with a language, on when you're working on the corpus of, yeah. Okay, so can we end the session now? Are there any questions?
I'm good. If anybody else has any other question.
Okay. Okay, can we end the session now? Okay. Nitin.